Perhaps the best series of lectures on undergraduate physics are by the physicist Richard Feynman. And he has a set of books called the Feynman Lectures in Physics. And if you're interested at all in science, I highly recommend getting this series. It's basically the same class that you're taking now, but looked at by a world-class physicist in a way that nobody else really has done since. I would use that textbook in this class, except it's about 40 or 50 years old, and it doesn't have any problems in it. But he talks about conservation laws in his book, and he gives an example that's better than any other that I've seen. So I'm pretty much going to be giving you, the example verbatim from his book. So he says, let's say we have a mother, and she stays at home with her son, and in the morning she puts him in his room, and he has 28 blocks. So she drops him off in his room, she goes back in the living room, does some work for a little while, and checks on him a little while later, and there's still 28 blocks. It doesn't matter what he did with them. It doesn't matter if he took them and threw them against the wall. It doesn't matter if he stacked them up one on top of the other, if he lined them up in a row. Anything that he did, there's still always 28 blocks. But then one day she comes in and she finds that all of a sudden there's only 27. Now what happened? So she looks around the room, eventually looks under the carpet and finds the missing block, and so we're back to 28. And his mother, being very clever, comes up with a hypothesis. She says that the number of blocks seems to be constant no matter what happens. Well, but then she comes in the next day, and now there's only 26 blocks. Well, she looks under the rug, and it's not there. She looks under the bed. It's not there. She looks in the closet. She throws all of his clothes out of the hamper. She looks in all of his drawers. She tears his room apart looking for these 2 blocks, and can't find them at all. So as she's cleaning up his room, she looks out the window and all of a sudden realizes that it was open. And there, sitting outside the window, are the missing 2 blocks. So once again, we found the 2 blocks. We're back to 28, and his mother regains her sanity. But then something really astonishing happens. She goes in the next day after a little while, and now all of a sudden there's 30. So there's 2 extra blocks. Now missing blocks was strange enough, but extra blocks coming in is just completely mind-boggling. Where could these extra blocks have come from? So she suddenly remembers that her son had a friend visit for a little while, Bruce, and she looks at all the blocks and sees 2 blocks that weren't there before, and realizes when Bruce's mother calls him that he had left 2 blocks there. So she gives Bruce back his blocks, and sure enough, we're back to 28. Well, she goes in the next day. She isn't that surprised that she only finds 25 blocks, because every day there seems to be something happening to these blocks, but they can always be accounted for. And she sees a box in her son's room and knows that's where the blocks are. But as she goes to open it, there's a sign on it, and it says, "Do not open this box, please." So now, if you can put aside for the moment that her, infant child was able to write, "Do not open this box," we have the question, if she's not going to open the box, how can she find out if the other 3 blocks are actually in there? Well, the mother's very clever, and she devises a scheme to do this. She says, well, let's say we have the number of blocks we can see, which in this case is 25. Now let's say we take the weight, so she takes the box and weighs it and finds out the weight of the box. And then one day, when she knows there's nothing in the box, she also weighs the box. And so the difference between the weight of the box and the weight that she's measured with blocks in it is going to be W minus WB. So that's the weight of the blocks that are in the box. And then if she divides that by the weight of a block, once again, we see that this is a constant, and in this case that constant is 28. So she's found a way to count blocks that she can't even see. And this goes on again. There's lots of different permutations that can go on here. For example, she's putting her son in the bathtub, and the bathtub water is very dirty, so she can't see the blocks. So she realizes she needs to add another term to this. If we take the height that she measures the water and subtracts the height of the water before the blocks were in it, because she knows every day that she puts exactly the same amount of water in, say 6 inches, and then divides by the height that the water goes up by just 1 block, once again we still have that same constant, 28. So every time something new happens, upon further investigation, there's always a new term, there's always a new law that we can add in that accounts for these blocks. Okay? This is what energy is and how energy is conserved. With one difference. With energy, there are no blocks.